Have you ever stopped to think that nothing in the universe ever stands still? From teeny atoms to giant galaxies, everything is spinning, orbiting, and dancing in motion. But why is everything turning? And what does that tells us about how the universe was born? Let us find out. The cosmic dance. The universe is like a grand cosmic ballet. Everything is in motion. The moon orbits the earth. The earth spins on its axis and orbits the sun. And the sun itself travels around the center of Milky Way galaxy. But that's not all. Our Milky Way is not standing still either. It moves around the gravitational center of a huge cluster of more than 50 galaxies called the local group. And this cluster also belongs to an even bigger family, the Virgo supercluster. So everything from moon to galaxies is part of an endless chain of rotations within rotations, like gears inside a cosmic machine. Why motion matters? This universal motion is not just beautiful, it is essential. Even our space missions depend on it. Before landing on the moon, spacecraft first have to enter orbit around the Earth, then orbit around the moon, and finally make a controlled descent. Without understanding how rotation and gravity work together, space travel would not even be possible. Rotation is the key that helps astronauts navigate the silent sea of space. The hidden spin of particles. But motion does not just happen in space. Even at the microscopic level, things are spinning. Inside every atom, electrons orbit around the nucleus. And beyond that, every subatomic particle, whether it's an electron, proton, or neutron, has something called spin. Now, this spin is not like a planet literally rotating. It's a kind of intrinsic angular momentum, a built-in property of particles. It's as fundamental as mass or electric charge. This spin even creates teeny magnetic fields. making it one of the basic forces that shape the universe. In short, spin is the DNA of motion itself. From particles to planets. When matter started coming together under the pull of gravity, it naturally began to rotate. That is how stars, planets, and galaxies formed. This rotation or angular momentum determines whether a planet spins on its own axis like Earth or revolves around another body like Earth around the Sun. Rotation also helps explain why most planets and stars are spherical. Gravity pulls everything inward, while spin spreads this force evenly, shaping these objects into round forms. So rotation does not just make things move, it gives them shape, balance, and stability. Why planets don't crash? You might be wondering, with so many objects spinning and orbiting, why don't planets crash into each other? If everything were still, gravity would pull all matter into one giant clump. But because every object moves at a different speed and direction, the result is a beautiful balance, like a cosmic dance where every step is guided by inertia. Inertia is the rule that says an object in motion stays in motion unless something stops it. And in the vacuum of space, there is almost nothing to stop motion. So it continues for billions of years. This eternal motion is described by the law of conservation of angular momentum, one of the universe's most powerful laws. Escaping gravity. Now let us talk about escaping this motion. If you want to leave Earth, you need to reach what scientists call escape velocity, the minimum speed needed to break free from gravity. For Earth, that is 11.2 kilometers per second. over 40,000 kilometers per hour. But even then, you did still be trapped inside the sun's gravitational pull. To leave the solar system, you did need to move at 43.5 kilometers per second. That is how a spacecraft like Voyager 1 and 2 managed to reach interstellar space. They used a brilliant trick called gravitational assist, slingshotting around giant planets like Jupiter and Saturn to gain speed without using extra fuel. By borrowing energy from these planets' gravity, they reached incredible speeds, all while conserving momentum. The ultimate escape. But what if we wanted to escape the entire Milky Way galaxy? You did need a speed of about 537 kilometers per second. That is nearly 2 million kilometers per hour. At that scale, space truly becomes unimaginable. The mystery of universal spin. Here is the biggest question of all. Why has everything been spinning since the very beginning? Did the universe itself start with a rotation? Some scientists think so. They have found a slight pattern around 1 to 2%. More galaxies seem to spin in one direction than the other. If this is true, it could mean the universe was born with a slight twist. A primordial spin that set everything in motion. Some even believe this might relate to dark energy, the mysterious force that pushes galaxies apart. Maybe dark energy is not a strange substance at all. Maybe it's just the effect of a slow, massive rotation of the entire cosmos. The slow spin of the universe. So far, scientists have not found solid proof. The cosmic microwave background, the oldest light in the universe, shows no clear sign of rotation. But maybe the universe is spinning so slowly that we just can't detect it yet. Some theories suggest it might take 6 billion years for the universe to complete a single turn. At that speed, Of course, it feels perfectly still to us. Now the conclusion. The subatomic particles to galaxy, everything is spinning. We live inside a cosmic engine powered by motion, gravity, and time. And we are teeny gears in this infinite system. So next time you look up at the stars, remember, you are not standing still. You are spinning, orbiting, and gliding through space at thousands of kilometers per second. Part of the eternal dance of the universe. If you enjoyed exploring this cosmic mystery, make sure to like, share, and subscribe to Cosmic Mysteries. Tell us in the comments, why do you think everything spins? Keep looking up, because every time you do, you are watching the universe dance.